Hey YouTubers, we're going to talk about another example of stoichiometry and solutions. And let's take a look at the question. Calculate the mass of barium sulfate formed when excess amount of sodium sulfate solution is added to barium chloride. And the molarity of sodium sulfate is 0.2 moles per cubic decimeters. The molarity of barium chloride is 0.5 moles per cubic decimeters, and the volume of barium chloride is 0.5 cubic decimeters. Now, we want to find out the mass of barium sulfate. And before we do anything, as usual, we need to write down the balanced equation for the reaction of sodium sulfate and barium chloride. So, here we go. Barium chloride, and that's an aqueous solution, with sodium sulfate, giving barium sulfate, and that's a precipitate, okay? We know that by the solubility rules. You covered that a little later. And chloride, and that's aqueous. And you have 2 moles of sodium chloride made. So 1 mole of sodium sulfate reacts with 1 mole of barium chloride to form 1 mole of barium sulfate and 2 moles of sodium chloride. All right, with that, we will now determine the mass of barium sulfate. Now, which set of information should we use? Should we use the information by using the information given for sodium sulfate, or should we use the information given for barium chloride? By looking at sodium sulfate, you can see we have limited pieces of information for that, because we cannot cancel out the volume of the unit volume in the concentration of sodium sulfate. But we can take this value, 0.5 cubic decimeters, multiply it by the concentration of barium chloride to cancel out the units of volume. Okay? So that's what we'll do. Let's lower the camera. So I have 0.5 cubic decimeters multiplied by 0.5 moles per cubic decimeters. And what I did is I'm going to cancel out this unit, and I'll multiply it across, and I should get 0.25 moles of barium chloride. So this is the amount of barium chloride that I've used, okay? Now, how much barium sulfate will be made? To determine that, we look at the molar ratio between barium chloride and barium sulfate. And barium chloride has the same amount of moles with barium sulfate, a 1-to-1 relationship. So that means the amount of barium sulfate that I have should also be 0.25 moles. Okay, a quarter of a mole. And with that information, I can now multiply it by the molar mass, which is 233 grams per mole. That is the MR, the relative mass of barium sulfate, and punch it into the calculator, and we should get an answer, which I don't have that right now. So it's 1/4 of this value. Okay. Running around, just right back here, gonna have 233 multiplied by 1/4, that's 58.25. So there you go, 58.25 grams of barium sulfate. Okay, so that's the amount of mass formed when you complete this reaction. Now for the second problem, calculate the minimum volume of sodium sulfate solution needed to precipitate the barium ions from barium chloride solution. Well, again, what we need is to figure out the moles of sodium sulfate that we use. Okay, so I'm just going to delete this part here. So now we're going to compare the stoichiometric ratio, the molar ratio between barium chloride and sodium sulfate. Again, it's the one-to-one relationship, so I have also used 0.25 moles of sodium sulfate. That's the minimum amount of moles of sodium sulfate that I used. Now convert that to volume, okay? So what do we do now? Yes, we would take 0.25 moles and divide it by the concentration of sodium sulfate, because the concentration of sodium sulfate is 0.2 moles per cubic decimeters, okay? And I would cancel out the unit of moles, and I would get an answer. So it's 0.25 divided by 0.2, and that's 1 1/4. 1.25 cubic decimeters of sodium sulfate needed to complete this reaction. So that is the minimum volume of sodium sulfate solution I would need.